Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. Before we get into this month's episode, I wanted to take just a quick moment to tell you about AIBS's new professional development program, which is Writing for Impact and Influence. The idea behind the program is to help scientists reach broad audiences through pieces like press releases, blogs, stakeholder memoranda, and other professional communications that aren't typically covered in secondary education classes in English or in science. And our aim is to really give you the opportunity to build an important professional skill with a minimal time commitment. We're really excited about it, so I'll include a link in the show notes, and I hope you'll have a look. For this episode, I'm joined by Dr. Thomas Newsome, who's a postdoctoral research fellow at Deakin University and the University of Sydney. He's here to talk to us about large predators, animals like wolves, and specifically what happens to them when they expand their ranges into areas that have a lot of people. We focus on their diets in particular and how eating food from human sources, things like livestock and garbage, can change their behavior and social structures and even create distinct genetic populations. And that last point has some implications of its own that are very interesting, which I'll let Dr. Newsome describe. So let's get straight to the interview. Thank you very much for joining me today.
Thank you for having me.
So, Dr. Newsome, one of the main premises of your article is that we're living in a world where human influence is almost ubiquitous. And I was wondering if you could just talk to us a little bit about that.
Sure. Well, there's growing recognition and understanding that the world is undergoing rapid environmental change, and most of that change is human-induced, in part because of the modifications that we're making to the environment. And our article really focused on what the implications of that might be for wolves in particular and other large carnivores. And these species are frequently utilizing human-provided foods, such as garbage and livestock, over the prey that they might normally eat. And this has a lot of implications for understanding their ecological role and how they interact with other species in the environment. And interestingly, at least for grey wolves, the use of human-provided foods presents a scenario similar to the way in which they were originally domesticated by humans some 14,000 years ago. So the scenario where these large predators like wolves are utilizing human-provided foods and coming in close contact with humans has broader consequences for understanding how humans can modify species, and hence the title of our paper, Making a New Dog, ?
Okay, yeah, and that's fascinating, particularly because, obviously with the first domestication event of gray wolves, we ended up with an entirely different species. I was wondering if you could walk us through that initial speciation event just a little bit. What's the basic version of humans' history with dogs?
Sure. Well, the exact timing and location is a subject of ongoing debate, but it is generally accepted that around 14,000 years ago, there was a domestication process. And what isn't debated is that there was likely a founder group of wolves who were attracted to human camps to scavenge kills or to take kills that weren't used or food that wasn't being used by humans. And that actually invoked a bit of a natural selection process or genetic drift of these populations away from more wilder wolves that were persisting on wild prey. After that, however, there was a more cultural process where humans started to take pups. They then bred for particular traits, in particular tameness, which is a sort of link to the domestication process. And following that, there was a strong artificial selection process for the traits that we see in domestic dogs today. But what is the point that we're really getting at in our article is that we have a process where wolves and other large carnivores are utilizing human-provided foods, which is akin to those first initial steps which I outlined.
Okay, and speaking about that phenomenon, where are you seeing that? Where are wolves, eating human-provided foods? What are those foods, and what is increasing their availability?
Sure, the two main areas, and they're also areas where wolves are returning to many landscapes after a period of widespread human persecution. North America and in Europe. More so in Europe, they are returning to human-modified landscapes where they frequently use or take livestock, either killing them directly or taking carcasses in the field. And in areas like Italy, for example, they've documented wolves frequently utilizing garbage. Now, most of the wolves are only just returning to more human-modified environments in North America. However, it's likely that the wolves would start to take these sorts of foods if they are provided by humans.
Okay, and why are the wolves reappearing in these areas? I think most of our listeners will be familiar with, the greater Yellowstone reintroductions, but this seems to be a broader phenomenon, and I'm wondering why it's occurring now.
I think there's been an ongoing shift in the way these species are being managed and the legislation that protects them. And so following the sort of Endangered Species Act in the US and about 20 years of debate, wolves were returned to ecosystems where humans had removed them after about a 70-year absence. And from that, and following protections of these species, they were afforded the ability to breed up and to disperse and to move into areas where previously and historically there had been intensive control that essentially wiped these species out. In Europe, the same is occurring. However, there hasn't been a reintroduction project in Europe like that was undertaken in Yellowstone. These carnivores, including wolves and bears and lynx and wolverines, for example, have been afforded protections under the legislation, and they're actually naturally recolonizing many of the landscapes where they formerly used to occur.
Okay, so we've got these large carnivores that are re-entering areas that are, been heavily disturbed by human activity, and they're encountering a different environment. And are they responding to that in any sort of uniform ways or predictable ways? What are we seeing, generally speaking, with that?
I think we can glean some lessons from dietary studies and looking at the things that they eat, and in particular. We do know that wolves and other large carnivores typically prefer large ungulate prey. And if that prey is decreasing in their diet, which does occur naturally, they often switch to smaller prey during that process where their main prey declines. However, in circumstances where wild ungulate populations aren't in good numbers or where there's little alternative prey for these animals to switch to, we often see that wolves are turning to food that are provided by humans, such as livestock or garbage.
Okay, so this would be a phenomenon where, rather than, eating elk or a white-tailed deer, for instance, the wolves would turn to livestock.
That is a possibility if there isn't an alternative source of prey that they would normally switch to when their ungulate prey declines. A good example is beavers. Beavers are often switched to by wolves when their main prey declines, and they can be a primary source of food during ungulate shortages. However, if they aren't available, well, they're going to have to look for food elsewhere, and that might actually force them to pushing into areas where humans might have that food available.
Okay, and what happens to wolves when they are exposed to human food sources? Does it alter their behavior? What are the general characteristics of wolves that have been encountering human food?
I think the studies are actually missing in that area, and we're probably only just starting to learn about what the possible implications are. And so one of the things we did in our article is actually learn lessons from other species to work out, well, what are the possible consequences for wolves? One of the good examples one of the best examples that we linked to was the case of dingoes in Australia, which I studied personally and know the most about. And in that case, dingoes that I was studying in the Tanami Desert, which is in central Australia, were attracted to a food source around a mining camp, and they also had access to livestock and carcasses on a cattle station. And the populations of dingoes that had access to these food sources typically had smaller home ranges, they had larger group sizes, and the percentage of inbreeding was a lot higher. They also had high rates of hybridization with domestic dogs in these areas. And more broadly, the population of dingoes that utilize this human-provided foods actually were a genetically distinct cluster from those in the wild areas. So what we, in a sense, had was a population of dingoes that ended up being separated from the broader population, and they also had very different ecological traits.
Okay, so you had a large difference between the behaviors of dingoes that were not fed human foods and those that were able to get human foods. Another thing you talked about was hybridization. And I'm wondering, in North America, something that's spoken about very frequently is the wolf-coyote hybrid and the wolf-coyote domestic dog hybrid, and, its various effects on ungulates in North America. And I'm wondering if that sort of phenomenon is related at all to this.
It can be if the human-provided food sources provide a source or a sink that acts as an area where coyotes and wolves might interact and potentially form a relationship and then breed. So these might be garbage tips or carcass dumps or things like that, where these carnivores are attracted to each other and their contact with each other is increased because of that. However, the initial sort of wolf and coyote hybridization has mostly been linked to areas where humans had decreased the wolf population. These wolves had decreased access to mates, and that allowed coyotes to infiltrate, their society and inbreed and hybridize and interbreed with these wild wolves.
So that's another phenomenon related to human intervention, but perhaps not exactly the same one.
Yes, and it's a common one as well, though, because in many parts of the world we still control or have harvesting of wolves, and that could increase rates of hybridization if there are changes to the wolf pack structures and socialities such that it allows smaller carnivores to infiltrate into their packs.
Okay, so you've highlighted some phenomena that affect behavior and could ultimately perhaps lead to a speciation event, and are creating these genetic clusters. And I'm wondering, what's the end game there? Do we expect this type of thing to have a negative effect ultimately on species, to cause their decline or to result in their being better adapted to these circumstances? What do you expect to see, and is that predictable?
I think we can expect both. Firstly, in relation to their ecological role, if large carnivores like wolves are only eating human-provided foods, it's very unlikely that they're going to exert the strong effects on ecosystems that we might expect, or that we might expect from what we've seen from the wolves in Yellowstone, for example. But secondly, if wolves are coming increasingly in contact with humans, it has the potential to increase human-wildlife conflicts and potentially increase the mortality of those wolves as well. So I think those are two of the negative consequences that could come out of wolves being forced to or being attracted to human-provided foods.
So you could have a situation in which, you reintroduce wolves into an area, or you allow them to repopulate an area where they had previously lived. And rather than having, the depressive effect on white-tailed deer or elk populations, you instead have, wolves that are actively seeking out, the livestock ranches, and making all of the livestock ranchers' fears come true about wolf predation. And then that could become an ingrained behavior.
It could become an ingrained behaviour. I guess what we do know is that where there are healthy populations of ungulates, wolves typically prefer and take them when they're available. So depletion of prey is likely to be a factor that would exacerbate wolves being forced to continually take anthropogenic foods like livestock.
That's not something I thought about before. So wolves will actually actively, prefer wild prey versus, anthropogenic prey.
I think most of the evidence is anecdotal, but if you look at their diet across the globe, yes, livestock do feature, but it's typically a low percentage. And in all the areas where there are healthy populations of prey and alternative prey, small prey that they might switch to if the ungulates decline, then the amount of livestock and other anthropogenic foods in wolf diet, and other large carnivores for that matter, is virtually non-existent and very minimal. Okay,
and your article also discussed evidence from a couple of other species, in particular red foxes and bears of various subtypes. And I was wondering, could you walk us through each of those perhaps, and kind of tell us how that might relate to this situation, or are we seeing similar things in those species?
Sure, it's sort of an extension of the effects we saw with the dingo. For the red fox example I used, that was an example of a group of red foxes that were attracted to an urban environment, attracted to the foods and the resources that were available there, this founder group of foxes ended up being a separate or genetically distinct population cluster from the surrounding red foxes in the region. So that's an example of, I guess, a founder effect, where a small number of individuals are attracted to a source, they breed with each other, and they end up being a genetically distinct population cluster. In the case of the bears that I was talking about, this sort of links back to the ways in which their diet is altered. For example, there's many studies that show that black bears will happily eat and survive off garbage, and that in turn can actually increase their survivability. However, that survivorship might decline if there is increased human-caused mortality on the bears. So in the case of black bears that I was mentioning, they actually had higher age-specific mortality, which was induced by human-wildlife or human-bear conflict, and higher mortality that was put onto those bears.
Now, was that higher bear mortality a result of human culling as a result of specific conflict, or was it just greater likelihood of contact in general?
Typically, it's a number of causes of the mortality. This might be from being hit by cars, but also just humans taking out bears that come into conflict with humans.
Okay, that makes sense. And so, we've kind of talked about the ways in which this could be problematic, having large predators or large carnivores of any sort coming increasingly in contact with human beings and potentially altering their behaviors in order to, make use of human-provided foodstuffs. What I'm wondering is there a good way that we have on hand to prevent this? Is there anything that we can do, as these animals repopulate the areas, to increase the likelihood that they will rely on traditional food sources?
So I think the first step is to make sure that those traditional food sources are actually available. So that might mean restoring ungulates to areas where that might be possible. If these ungulate prey are declined for whatever reason, if they have been overhunted or the habitat's depleted, then I think where the circumstances allow it, providing or restoring the main prey of these larger carnivores is the first step. And also thinking a bit more broadly that if you restore the main prey, you also need to restore the alternative prey to provide a buffer for these large carnivores to survive on when their main prey declines. The second part, though, is actually managing the food waste that humans produce. And this is actually quite a serious issue across the globe. Vast quantities of foods are disposed in garbage tips that are not secured properly, that allow animals to readily come in and utilize the food source. And then huge and vast quantities of carcasses are left either to rot in the field, they're left in carcass dumps, and even this can be extended to the carcasses that hunters leave across the landscape. That is a source of human-provided food as well. So I think managing these resources in combination with providing the right habitat and right prey for these animals to survive in are the two key factors that need to be addressed.
So basically a case of reducing the amount of anthropogenic food sources and increasing the amount of natural food sources.
Exactly, yes.
One thing I was wondering about, what's the state of prey sources like in the world outside of North America? Because I think, most of our listenership is probably, based in North America, but I don't want to be too, centralized in that region. So, what I'm kind of thinking about is in the U.S., for instance, the white-tailed deer population is enormous and, probably at a higher level than it ever has been historically. But is that the case elsewhere? Is that the case, in Spain, for instance, where wolves are repopulating areas, or anywhere else in the world? Are there broader trends that are different from what we see here?
From what I've read and talked about with colleagues in Europe, there are certainly examples there where ungulate populations are depleted, and this would mean that these prey aren't available for the carnivores when they return to these, or if they return to these systems. From my own personal experience working mostly in Australia, there's certainly a lot of prey available for dingoes, but a lot of the prey that was historically available isn't as well. So Australia has, unfortunately, a very high extinction rate, and we've had 30 mammals go to extinction in the last 200 years. A lot of these species were small to medium-sized mammals that would have been prey for dingoes when they were available. So certainly the high loss of mammals across the globe and the high extinction rates in some areas means that there has been a depleted prey source for the carnivores that are surviving today. And that in turn could mean that they're actually doing different things to what they were, say, 1,000 years ago before Europeans had a huge impact.
So just out of curiosity, dingoes, what is their primary prey source?
Typically in arid Australia, it's large kangaroos. The red kangaroo is their primary prey source. They also switch to rabbits when they come available, but they can also have a very diverse diet and focus solely on small lizards like the blue-tongued lizard. In the Tanami Desert where I work, the primary prey for dingoes, or the number one prey item for dingoes, was the blue-tongued lizard. So they can also survive off fruits and berries and small mammals and reptiles as well. So I would put the dingo as being ecologically equivalent to a coyote with a very diverse diet where they can survive off a wider range of foodstuffs. When you start to move into the larger carnivores, that's when they have higher energetic requirements and typically prefer the larger ungulate prey.
I'm curious now, what's next for this research? Where would it be really useful to have more data in studying these issues?
Sure. Well, I think the fact that we've already got examples of changes to group sizes, diets, home range, sociality, differentiation in populations with other carnivores, I think when considering wolves, what we need to be looking at now is what is the difference, or what are the different population structures or the ecological roles of wolves that are persisting in more human-modified environments versus those in more natural environments such as Yellowstone. And we might actually expect very different ecological effects of wolves in these human-modified environments. And we might also see extension of the effects that we saw with the other examples that we use in terms of changes in their group sizes and diets and sociality. And that in turn could give us some insights into how these species are utilizing surviving in this landscape, and also what we might need to do to ensure their ongoing survival and maximize their ability to perform their functional ecological role.
That seems like really important work too, because it strikes me that there's some potential for conservationists to be blindsided by the effects of these reintroductions if they're not adequately prepared for, and if we don't have a good amount of insight into what we should actually be expecting.
Sure, and most of these animals are highly adaptable, and when you give them the right circumstances, they will do, or the right habitat and the prey, they will do very well. So one of the things I'd like to see is that if anthropogenic foods start to come up in the diets of wolves and other large carnivores, then this should be the starting point for investigating, maybe we're not providing, or maybe these animals don't have access to the resources that they need. What do we need to do to turn that around? So it could actually provide, before we get to a stage where we have increased human-wildlife conflict, it could actually provide the starting point for initiating steps to reverse the potential negative effects that could occur.
That sounds like a strong case for continued vigilance. Let's leave it right there. Dr. Newsome, thank you very much for joining me.
Thank you for having me.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.